Good morning, students. Today we will start chapter number 10, Vector Algebra. In this chapter, we will study what is a vector quantity and how to multiply two vectors and what type of product we will get, whether scalar or vector. Now, what type of quantities are known as vector quantities? First thing we have to discuss, I think up to 10th class we have studied about the physics. As suppose point A and point B are given to you. If I want to reach from point A to point B, maybe the path you have traveled and you reach at point B like this, and maybe the distance up to like this. Or it means what? Here I am traveling the distance. Distance means only magnitude matters. Only we are discussing about the magnitude. When I'm talking about when I directed from A to B, direct, it means what? Magnitude as well as in the direction I have mentioned here. It means we are talking about the displacement. There's a difference between the vector and scalar quantity. Here distance is a scalar quantity and displacement is a vector quantity. Here we can see the definition of the vector, a quantity which has magnitude as well as direction is known as vector quantity. A quantity that has magnitude as well as direction is called a vector. Notice that the directed line segment is a vector and denoted as AB vector like this. It means here in the above, you can see here direction, arrow is given, it means direction is given to you. In the third, only direction is given here, first and second. In the third part, direction as well as magnitude both are mentioned here. Magnitude A vector having magnitude A in the direction from A to B. Here this third part shows this is a vector. In the first and second, it is just only direction is shown here. In the third part, direction as well as magnitude is given. It means this is a vector quantity. So definition of the vector is there. And how to write down the vector? Like this. Name of the small letter and arrow. If it is from A to B, then arrow should be like this, A to B. Or you can write A, B and like this. This is a way to write down the vector quantity. The point A from where the vector AB starts is called its initial point, and the point B where it ends is called the terminal point. It means two points are there. From where it starts, it is the initial point. Where it ends, the point is terminal point. And the distance between this initial and terminal point is known as the magnitude of that vector. And it is denoted by like this, magnitude, absolute sign is there like this. Magnitude of vector AB, or you can say vector A. The arrow indicates the direction of the vector. Now first thing which you have to further study, that is the position vector. Position of a point with respect to the given origin, that is known as the position vector. Here we can see here is the point P lying, because we are talking about the three-dimensional geometry. So here the coordinates will be X, Y and Z. And the P, the position of this P with respect to this origin, that is OP, and OP is the position vector of P, and it is denoted by R vector. Suppose the points are A, B and C, and the vectors are denoted A vector, B vector and C vector, and these are OA, OB and OC are the vectors with respect to the origin. The direction cosines. Direction cosines means what? Vector makes an angle with the positive direction of x-axis, positive direction of y-axis, and with the positive direction of z-axis. The cos of that angle is known as the cosine of the given vector. It means here the vector OP is given. The vector OP makes an angle with the positive direction of x-axis y-axis and z-axis, the cos of these angle is known as the cosine of the vector OP. Okay. Suppose alpha, beta, gamma are the angles which this vector makes with the positive direction of x-axis, y-axis, and z-axis. So cos alpha, cos beta, and cos gamma are the direction cosines of the given vector OP. Now further, what is a zero vector? Zero vector means a vector whose magnitude is zero. And what about the direction? Just read the statement. A vector whose initial and terminal points coincide is called a zero vector. We can say its magnitude is zero and denoted by the zero, and the sign is there, arrow is there. Zero vector cannot be assigned a definite direction as it has zero magnitude. Or alternatively, otherwise it may be regarded as having any direction. So what? The zero vector is a vector which has zero magnitude and its direction is not to be assigned, not assigned direction. Unit vector, a vector whose magnitude is unity, it means 1 unit, is called the unit vector. The vector unit is the in the direction of the given vector is denoted by like this, a cap. If a vector is given to you, you want to find out the a cap. A cap means unit vector. Then divide that vector by its magnitude, then you will get the unit vector. Co-initial points, two or more vectors having same initial point are called co-initial points. And collinear vectors, two or more vectors are said to be collinear if they are parallel to the same line. If two vectors are parallel to the same line are known as the collinear vectors. Equal vectors, two vectors A and B are said to be equal vectors if they have the same magnitude and direction regardless of the position of their initial point, and written as A vector is equal to B vector. Negative vector means a vector whose magnitude is same but its direction is opposite to the given vector. Suppose a vector A is given, if its direction is opposite, it will be minus of A. If it is AB, you can write it will be minus of, or you can say negative of AB, or you can say it is BA, like this. These are the few basic definitions of the vector. Now example number first. Represent graphically a displacement of 40 kilometer 30 degree west of south. Now west of south means from south you move towards west, and how many degrees? 30 degree, and represent like this. This is the way to represent the question like this. Now classify the measures as scalar and vector quantity. 5 seconds. This is what? Scalar quantity or vector quantity? And second one, 1000 centimeter cube. What are these quantities? Scalar or vector? These are the scalar quantities. Now newtons. This is a unit of force. So force is what? Direction matters in this case of the force. It means it is a vector quantity. And 30 kilometer per hour. 30 meter per kilometer, that is speed. And speed is a scalar quantity. Here 10 gram per centimeter cube. This is the density. Density is also a scalar quantity. And next one is the velocity. Meter per second. Towards the north. Direction is given. And it is a velocity, and velocity is a vector quantity. So in the questions you have to just, 1 mark questions, you have to just identify whether the given quantity is the scalar quantity or the vector quantity. Or collinear vectors, equal vector, and co-initial vectors. You can check by using the definition. The given figure is here, 10.5 figure is given. Now here you have to check which vectors are collinear vectors. Vector A, vector C, and vector D. these are the collinear vectors. And equal vectors, A and C, equal magnitude, same direction. Co-initial vectors, whose initial point is same. Vectors are whose initial point is same, B, C and D. Initial point is same. That's why these are the co-initial vectors. Now in the 10.1 exercise, you have to just identify whether the given quantity is a scalar quantity or a vector quantity. And few true false are given in the question. Now let's see in the exercise for 10.2 what type of questions are there. Addition of vectors. How to add the given vectors? If vector AB is given, here it is figure is given. Initial point is this one, A to B. Now from terminal of AB, you move for up to C, BC, and join initial of the AB and terminal of BC. Then you will get the magnitude AC. It means AB plus BC is equal to AC. This you have to remember. This is a triangle law of vector addition. But what we have done, like this, in this direction, this is AB, B to now C, arrow sign, you can see B to C. Now join B to C, this is the addition of vector AB and BC. This is AC vector and direction will be like this. Carefully you have to mention the direction. How to add them? You can write like this. How to subtract? If A vector is given, B vector is given, this is AC is the vector given here, the direction is this one. Now B moves downward, then you will get the negative of B, that is minus of B. When you, this is A to B and B to C. When you join A to C, you are getting the vector A plus minus of vector B. It means A minus B vector. Now parallelogram law of vector addition, properties of vector addition. A plus B is equal to B plus A. And here's the associative law. A plus B plus C is equal to A plus B plus C. Now multiplication of vector by scalar quantity. If a vector is given to you, you want lambda times of a vector A, then it means you are getting this property. Lambda times of A vector is equal to lambda multiplied by magnitude of the vector A. Components of a vector, it means what? Components means part of the vector. Here we can see that X, Y and Z, three mutually perpendicular lines are given to you. Along x-axis I have taken a unit vector I, along y-axis I have taken the j vector, and along z-axis I have taken the k vector. And the magnitude of these vectors are 1. These are the unit vectors. Along x-axis, along y-axis, along z-axis. If I take a point A on the x-axis, the points of the point of A, A1, 0, 0, point of B 0, 1, 0, and point of C will be 0, 0, 1. And here when I write the vector along OX, that is the unit vector I, and along OY, that is J vector, that is the unit vector, and K is a unit vector along the Z axis. If I want to write down the P in the vector form, so I will write down Xi plus Yj plus Zk. How you can get? Now in this question, especially in the case of the 3 dimension, you have to visualize the figure. If you are unable to visualize, then it is difficult to do the question. And this part, this first part, P1Q is the front wall where you are sitting, and RS on the wall, on your behind wall, and this is a base, OP1 on the base, it means on the floor. You have to just assume this front wall, back wall, this is the base, and upper one is the roof of the R and P are lying in the roof of your room. And this P can be written as, when I write this point P in the vector form, that is equal to xi plus yj plus zk, that is R vector. You can see here xi, if this is yj, then this will be yj. If I got OP1, that is xi plus yj, if I solve this triangle, then I will get the OP, that is xi plus yj plus zk is equal to R vector. I have used here OQP1 triangle and OPP1 triangle. You can see these two are the right angle triangles. If you can visualize, it's easy to understand for you. As you can see here, OP1 can be calculated by taking the right angle triangle. Second right angle triangle is used and you will get this one, and this is a component form of the vector OP, that is R vector xi plus yj plus zk. If you want to calculate the magnitude of the OP vector, that will be equal to under the root x square plus y square plus z square. You can observe this by taking the two-dimensional geometry. So P point is given to you. If I want to calculate this point, suppose x and y are the coordinates, and this is O, origin. If I want to calculate the distance OP, this is O and this is P, then it is OP is what? It is a right angle triangle. You can use this distance OP. You can find x square plus y square under the root. And if I am taking the space and coordinates are x, y, and z, it means the magnitude will be x square plus y square plus z square under the root. Here are a few questions. Example number 4. Find the values of x, y, z so that the vectors, these are equal. If two vectors are equal, it means what? Their scalar parts are, scalar components are equal. It means here x will be equal to 2 and y will be equal to this 2 and z will be equal to 1. This is a 1 marks question. Now if A and B are given to you, you have to check whether magnitude of A and magnitude of B are equal or not. Yes, magnitudes are equal. Are the vectors A and B equal? No, vectors A and B are not equal because it is I and its magnitude is 1. It is 2 times of I and it is 2j and it is only j. But two vectors are not equal since their corresponding components are distinct. Okay. Now how to find out the unit vector of the given vector? I just told you the formula. Unit vector can be calculated by dividing the vector by its magnitude. Now calculate the magnitude of this vector, that is root 14. Divide this given vector by the root 14. You will get the new vectors, that is known as the A cap. If I want the vector which is having the magnitude different, suppose find a vector in the direction this has magnitude 3. If I calculated the magnitude, one magnitude vector, and after getting the one magnitude vector multiplying by 7, you will get the vector which is having the 7 magnitude. If it means procedure is what? First of all, you have to convert the given vector into the unit vector. And after converting into the unit vector, multiply that vector by the 7. Unit vector means one quantity, magnitude is 1, multiply by 7, it means 7 magnitude will be there. So this is the answer. Find the unit vector in the direction of the sum of the vectors this and this. It means first of all you have to add these two vectors. Add two vectors, you are getting the new vector, and you want the unit vector along this. It means what? You have to divide this vector by its magnitude, and magnitude is root 29. Divide the given vector A plus B by root 29. You will get the new vector that is known as the C vector, like this. Now write the direction ratios of the vector. A is equal to this, hence calculate its direction cosines. How to calculate the direction ratios? Direction ratios means the components of I, J, K, scalar components are known as the direction ratios. Here A is 1, B is 1, C is -2 here. These are the direction ratios. If I want direction cosines, first direction cosine L can be calculated by A upon magnitude of the vector A. Magnitude is root 6, 1 square plus 1 square plus -2 square, that is root 6. It means 1 upon root 6, direction cosine first. Second direction cosine 1 upon root 6. Third one will be C upon magnitude means -2 upon root 6. These are the direction cosines L, M and N, because L, M and are the notations to write the direction cosines. The vector joining the 2 points. Now vector joining the 2 points means how to get the vector when the 2 points are given. Suppose P1 and P2 two vectors are given in the space and the coordinates are x1, y1, z1 and P2 having coordinates x2, y2, z2. Then vector P1, P2 can be calculated by using the position vector OP2 minus OP1. You can see here P1 plus P2 can be calculated by OP2 minus OP1 because OP1 plus P1 P2 is equal to OP2 by using the triangle law. It means if 2 points are given, then you can find the vector. Find the vector joining the points P and Q. Here 2 points are given. We have studied the formula now. Now what to do to get the PQ vector? It means position vector OQ minus OP will get the vector PQ. What is the position vector? It means one OQ. It means -1 -2. And here is -2 -3, -2 -3. And -4 -0. You are getting -3i -5j -4k. This is a vector which is a PQ vector. Now how to get the vector when 2 points are given in the space? The next one is the section formula which we have studied in the 10th class for in the coordinate geometry. Now here how to get the in the vector form, how to apply the section formula. Here is the formula. P and Q are the 2 points and R is the point which is dividing this line segment into in the ratio m is to n. And we want OR. It means R vector. R vector can be calculated. Here is R vector can be calculated. M is multiplying to the vector, this one opposite to this. It will go there, M will go here. It means M will multiply the B vector and N will multiply the vector A. Here it is written MB vector plus NA vector upon M plus N. And when it is written in the external division, so then this plus sign will be replaced by minus, and when it is externally dividing the line segment. Here is a negative sign. You can see here, if the R point is dividing the line segment PQ externally, then you will write down the minus sign in the formula. Now how to apply this formula? We will do few examples. I think example will be there for that. Example number 11. Consider 2 points P and Q with position vector this OP and OQ, and here ratio is given 2:1. Internally and externally you have to write down the vector. For the internal division, we can write OR vector is equal to 2:1, means 2 will go with A plus B and 1 will go with this OP, and divided by sum of ratios 2 plus 1, you will get 5A upon 3. If it is the external division, then you have to apply the minus sign in the formula. This application of formula is there only. Show that the points are the vertices of right angled triangle. If these are the points of right angled triangle, it means we have to first find out AB vector. Line segments we have to find out. AB, BC and CA. AB means OP minus OA, B minus A vector. BC means O, position vector of C minus position vector of B. You will get the AB vector, BC vector and CA vector. Then get the magnitude and apply the Pythagoras. We got the magnitude. AB square is equal to 41 and the magnitude of B square and magnitude of C square are 6 and 35. Add them, you are getting the magnitude of AB square, means right angle triangle, because Pythagoras applied here. H square is equal to P square plus B square. Now same procedure you have to apply in the questions of 10.2 for the given exercise 10.2. Try the questions of exercise 10.2, 10.1 both. In next video we will discuss important questions of 10.2 exercise. Thank you. Have a nice day.